Thank you, Franz. Thank you for the introduction. So let's get started. My name is Łukasz Piątkowski. As Franz already said, I work as a Kubernetes platform architect for Giant Swarm, specializing actually in managed apps and managed services area. But today, my webinar will be about Kubernetes at its base and its core. So what's the plan? Today, I would like to give you actually a few ideas, a few areas and processes where you might expect some problems, some issues or challenges when you actually start your Kubernetes journey. So when you're trying to really deploy your first product in production environment on Kubernetes, this is where I think this webinar will be the most useful for you. But we will start with something even simpler, just to double check. We'll see if really your use case is a match for Kubernetes. And then we will move to this section where I would like to first of all focus on few areas of cluster and software running on the cluster management. And then I will focus on few processes. You will see why I think the processes are even more important than just having a look at the static area image during the webinar, I hope. So let's move to the first topic. Should you even use Kubernetes? First misconception that I often see is that people think that Kubernetes is like a very fixed set of services, a complete product that you can actually deploy, install, and well, run it, be happy about it, and so on. But in reality, I think what is closer to how Kubernetes deployments and production usage looks like is that Kubernetes is like a set of Lego bricks. So basically, you have a lot of options. You can build great things out of it, but not everything is standardized. You can move things around, you can switch things, you can choose different solutions and adjust them better to your needs. But that's something very important. That's an important property of Kubernetes. And you have to think about it from the very beginning that just Kubernetes as a project is not enough to actually run Kubernetes as a cluster. Some of the building blocks that create Kubernetes are already very strict and set in stone, and the API is stable, and well, you can use them to deploy and build your application, but still some things are left for you to pick and to choose. So basically, to use the bricks that you will have when creating your Kubernetes cluster, you might need a manual or some ideas, and most importantly, probably some requirements. So our suggestion is that when you are starting with Kubernetes, choose probably a single project or some very similar projects and a specific use case, and then try to run this and deploy this project or set of projects. Because otherwise, when you will see all the bricks lying around, all the fancy services, all the ways you can improve your cluster, it can turn into a wish list. So basically, you will see that this brings value and that brings value, but actually, you have to decide if you need this value, if you need those additional services. So make sure that you know what your use case is before you start, so that later you can pick out of all the bricks, all the components, all the projects available for Kubernetes, you can pick what really is needed for your specific use case. So implementing Kubernetes is not that easy, and make sure that when you do that, it's worth it, that you choose the parts, choose the elements that are really needed for your use case. You might get an impression that actually it's not a good idea to run Kubernetes, and that might be the case. I mean, Kubernetes is not the silver bullet in every possible situation. So there are definitely use cases that are better suited than others for Kubernetes. But the basic question is then why people love Kubernetes. There's a lot of buzz around Kubernetes for the last few years, right? And it's probably the fastest moving open source project right now in the world. So what's that great in Kubernetes? And I think that like the very basic and short answer that you can give is that it's the API. So basically, what makes Kubernetes great for Kubernetes users is the API, which provides you some very well-defined building blocks for your application. So you can basically create your application from some well-specified components, well-specified API elements, and you can easily connect them together to build a deployment that you need for your application. Additionally, because all applications that you deploy on Kubernetes are built from the same set of bricks, the same set of objects, API elements, and so on, you get some additional benefits like uniform management and monitoring API. And this can be a great advantage, especially on the operational level. So where does Kubernetes fit the best? Definitely not in like monolithic, non-replicated, heavy applications. That's probably a very bad use case for Kubernetes. The best ones are around microservices architecture and about rapid CI/CD, agile software delivery, software release pipelines. One important thing, if you want to use Kubernetes for the first time and you haven't already migrated towards the DevOps approach, is to know that you probably should be prepared for a change over here. I mean, when you prepare your application to run on Kubernetes, it's not just your application anymore. So it's not only about building the application and then handing it over to the operations team to run it somewhere, somehow. And now you are like directly involved into providing a code that will describe to Kubernetes cluster how your application should be deployed, how should it run on the cluster. So basically your developers like naturally tend towards the operational part of running your software, which is basically a great thing because it naturally naturally like allows you to go into the DevOps route, which is really what nicely matches Kubernetes philosophy. And I hope you will see this in this webinar as well. So because you're here, you probably want to use Kubernetes and you already gave some thought to it. I'm not spending any more time on that. I just want to use this image to point a few things. You as an architect, you are probably focused on running your application on the cluster. But here in this webinar, I'm already taking the DevOps route. So I'm not talking about your application only and what you need to do for your application to run on Kubernetes or something like that. I'm focusing on what it's like to run your Kubernetes cluster, including your application, because that's the DevOps approach. That's the like you need to be aware if you want to deploy your application. You need to be aware of the cluster as well. You need to know how it works because, like I said, there's a lot of like common ground between your application, how you deploy the application, how application runs on the cluster, and how cluster runs on its own. So this is all intervened over here. So if you have a look at this slide, the green part is your application. Obviously, it's not like up to scale. In a real world deployment, your application will be the most important thing, consuming the majority of resources probably and so on. But to show you how many different elements are involved into making your application run on Kubernetes, I prepared this diagram. And please note that we have grouped all the elements on the image into 3 color-coded areas. The blue one is the platform. So basically, by platform, I mean everything up from the hardware level that's needed to run your basic Kubernetes services. Then there are tools that enhance your Kubernetes experience. Basically, like I said, you need to add a few bricks, you need to add a few elements to build what you need. And this is orange on the picture. And only the green part is where you are, I mean, when your software that you run, that you make available to your customers is. So I will get back to this picture. Let's have it in mind. Because this shows a little bit what we really, where really the dragons are, where you can expect the challenges. So there's like day one. On day one, you install your Kubernetes, and right now it's actually pretty easy. I mean, there are many open source projects. kubeadm is probably the most well-known one for installing Kubernetes. And obviously, all the major infrastructure providers, cloud providers, they already have their own Kubernetes experience. So you can start a Kubernetes cluster with just one click or one API call, and that's it, and you have a cluster running. But that's not where the challenges are. The challenges start at day two, when you need to start to manage your cluster, because you have to think about managing your cluster if you want to have a stable cluster, and as a consequence, if you want to have a stable and great your experience for your application, stuff that you deploy on top of the cluster. So challenges come usually around a few topics, and I named those topics processes over here because after day two, it's no longer a task, it's a process. So you need to maintain your cluster, and with your cluster, you need to maintain your additional services. And with all of that, you need to maintain your application that you're preparing to be deployed on the cluster. So it's all a process. And I would like to pay attention to four processes, like starting, in my opinion, from the most difficult and most important to, well, also very important, but I will just pay a little bit less attention to them. So we start around updates, then we will talk about monitoring, then cluster management and security. I will really give you a few hints that will hopefully make your life and make your process of running these things easier. I could actually summarize all that I'm going to say about it in one sentence, which is automation is your friend. And that's like really essential. There are so many services, so many moving parts, so many services around that you need to automate stuff. And that's like something you really need to have if you're going to use Kubernetes. This might be like fully automated. This can be like semi-manual, semi-automatic. The scope might be different, but still without some automation to manage your Kubernetes cluster and your workloads on top of it, you will have a hard time. So keep this in mind. Automation is probably like part of Kubernetes requirements. So two things around automation. Automation in general is great, will help you harness the complexity of Kubernetes. But first of all, remember that automation now becomes like part of your solution, so part of the DevOps culture. I mean, Kubernetes will make it easy for you to migrate your teams, to migrate how you deploy and manage software into the DevOps perspective, DevOps culture, which is great, I think. And this also means what I already mentioned, that your application is now more than just its source code. So your application, also like your developers, DevOps teams, they also need to think about deploying the application and running the application, and not just like building the application and handing it over somewhere. So with that in mind, let's move to the first process I would like to address, which is updates. Let's move back for a second to this image. And right now, I will focus on updates of the blue part. So blue part is basically everything you need to run or your infrastructure provider needs to run. That depends on your use case. If you're on like bare metal or you use some Kubernetes provider, like cloud provider. But in general, you need to think about updates of the blue part. So blue part is basically system level effort. You need to focus on the platform. You need to focus on the nodes that are running your cluster. You need to focus on like your container runtime, and you need to focus on services that actually run the Kubernetes service. A few things to note and to keep in mind over here. First of all, as you remember, there are many moving parts out there. So there's like an operating system, kernel, container runtime, Kubernetes. Kubernetes itself keeps really crazy pace of releasing and developing new features. So basically, there's a new minor, like there's only one major release. All Kubernetes versions are named 1 point something. So there's a minor release every 3 months, and that's like scheduled. You can expect new Kubernetes version every 3 months, which means you should also aim for updating your platform every 3 months, which is really crazy pace. You want to focus on your application, right, and not on your platform. So yeah, that's how Kubernetes works. Two important things around this 3-month cycle to note. First one is that people often tend to stay one minor release behind. That's generally a good idea, and I would recommend it as well. Because, well, usually new release is around new features. If you don't need them, I mean, you are not one of the users really interested in the new supported cases, let others test that and stay one minor release behind. But don't allow yourself to just stay behind indefinitely, because Kubernetes actually forces you to do updates every few months or something around that, because all the minor releases are supported only for the last 3 minors. So basically, it means that your Kubernetes version that you run today, like freshly installed, will be supported only for 9 to 12 months, not longer. After that, you won't get any support, any additional releases for the version that you're running. So updates are unavoidable. You need to cope with updating the platform. And the problem is that Kubernetes updates can be risky. Like you've seen, we have many layers, like the operating system, so basically your Linux distribution, like the container runtime, where Docker is still the most popular, but you can use something else if you want to and have a reason to. And only then there are cluster services, the Kubernetes part, like the API server, like scheduler, and so on. The good news is that thanks to the Kubernetes architecture, you can do platform updates without any downtime, which is great. You can upgrade your masters first to the new release, and then one by one or in batch groups, I'll touch that in a minute, you can update your worker nodes, and you can do all of that without causing any downtime to your application. So this is great, but you have to pay attention. Obviously, when Kubernetes minor changes and there's a new release, it's mostly about new features. And well, it's not something that will probably cause you troubles, but also Kubernetes is changing and some features are getting deprecated. And if stuff gets deprecated, there's always a transition period when it's deprecated but still supported. But eventually, this won't be present in the release in the code anymore, and suddenly your perfectly working release, perfectly working application that runs on top of Kubernetes can fail just because you did Kubernetes cluster update. So a few things that hints that can save you a lot of headache. First of all, I already said that like the general answer to all the problems that I'm covering over here is automation. So within your automation, think from the very beginning about handling updates and basically be prepared to run an update every 3 months. As you've seen, there are many moving components: kernel, distribution, container runtime, Kubernetes versions, and so on. To limit the number of combinations between all of those elements that you can produce and that you need to test that work stable and work together, think about producing immutable operating system images that already include everything that you need to run your Kubernetes. So test one set, test it good, then keep it fixed, frozen, don't change any single version until you release a new image that is also tested that way. Don't do partial updates, don't change your machines that run your cluster live, immutable images, and this will save you a lot of headache. Next important thing, test your updates. I think this is obvious, Rafer, but the important thing here is reflecting production setup. Why is that important? For example, there's a notion, a mechanism of draining a node in Kubernetes. This basically works like that. You have a pool of workers, excuse me, and then during the update, you need to replace those workers one by one. So you basically take one node, you drain it, that's called a drain. So you basically remove all the workloads from the node. When the node is empty and doesn't run any workloads, you can remove it from the cluster. And before you do that, you basically start and create a new node, you join the cluster, so there's a free space, there are some resources that can be used to run the workload from the node that you are removing. And if you do this on like one-by-one basis, this should be a flawless update without any downtime for your application and so on. Still, the problem is that if you're testing this on a non-production-like setup, you can run into some issues in production that didn't happen in testing. Like a well-known example is you have a very loaded cluster node that runs a lot of applications. And these applications, they take a long time to stop. So basically, when you order them to stop, to free the node, to drain the node, and then remove it from the cluster, application under the load, the production load, can take a very long time to actually stop, and it might not be gracefully stopped, it can be killed, and so on. And suddenly it turns out that it's not that easy to gracefully remove a node from your cluster. Until when you test the update, you do the same in the testing environment, and for example, your application will be completely idle, its dynamic will be probably very different than the dynamic of the application, same version that you have in production setup. So keep that in mind, that until you really have like reflected the application, but also the workload that you have in production, your testing results might still be different. Second thing is plan your updates. I already said that when you update Kubernetes, you go first with masters, then you go with workers. But usually people run 3 masters, so it's easy to update them one by one. You update the first one. If the update is green, then you can roll another node, and you have your control plane, the masters, updated. But think about doing the same for the worker nodes. Obviously, you can't, like if you have hundreds of worker nodes, you can't do this one by one probably. But again, divide them into batches and start with just one node, then maybe do this for 2 nodes, then do them in batch of 10 or something like that, so that if anything fails for any reason and you have to give up on updating and do a rollback, you still have some capacity of the cluster left that is working without any problems, hopefully, and that your rollbacks takes shorter time, and the most important thing, it is less disruptive for your cluster. And one more thing, always check the changelog when the new minor of Kubernetes is released, and keep an eye especially on deprecation notices. One of the most famous, at least around 1.16 release, was around API versions. So as you probably seen already, all the components, API components of Kubernetes, like deployment, like service, like pod, they have API version that they implement. And especially when new features are moving from the beta stage to stable stage, there's a transition period when both of those API versions are supported, so both beta and stable, but eventually beta will be removed. And like in your manifests that you use to deploy your application, still use the beta annotation for API version, and you update your Kubernetes cluster, suddenly your perfectly working deployment can just fail because there's no such API version anymore. Okay, next layer of the whole stack that you use to run your application is the tooling. So basically the orange stuff over here, stuff mostly around monitoring, observability, but also exposing your services and so on. The most important thing over here is that if you think, well, I'm gonna run Kubernetes and that's it, you're probably wrong. Most probably, you will use a lot of tools that run on Kubernetes that enhance your monitoring, logging capabilities, traffic routing capabilities, and so on, which are not really included in Kubernetes by default. That's what I said, that Kubernetes is like a set of Lego bricks. So you get the manual, you get the bricks, but you might want to tune things for your specific use case. So just keep in mind that Kubernetes as a project doesn't include by default any networking driver, which is called CNI, your cloud provider probably installs that for you. But if you install on bare metal, it's up to you to choose a networking driver. There are no services exporters, so basically services that make your products that you run on top of Kubernetes available to the outside world, so your actual customers. And these are services like ingresses, like for example, Nginx Ingress Controller, or API gateways like Kong, or external DNS registration automation like external DNS project, and so on. There's nothing around monitoring, so we'll get back to this, but you definitely need one. There's nothing for log management. There's nothing for cloud provider identity management. So for example, if your pods, if applications that run in your pods in your Kubernetes deployment, if they want to access cloud providers API, you need to expose the necessary identity tokens to them. And that's another use case, backup tools, and so on and so on. Depending on your use case, you'll probably find a lot more. So that's something that people don't expect when they really start their journey into Kubernetes, that it's not only Kubernetes and your application, it's Kubernetes and tools and your application. So if from the list that I gave you on the previous slide, you think you could use some of them, then think also that you need to care about them. So each of these tools that I mentioned is at least a single project. Sometimes it's a set of projects, and you need to track their releases and do updates for them and so on. And you need to take into account platform updates here. So when you do platform update, you don't have to care about the platform and your application. You need to check if the new platform and your tools and your application still work together. So about tools, those hints are not that specific because again, this depends on your use case, but assume that you will use at least a few tools from the very beginning and include that in your automation and include that in your updating plan. So remember, like the three main layers, the cluster, like the Kubernetes software, your tools that you chose for your specific use case, and then your application. And you have to manage your updates on each of these layers. And you need to make sure that all of these layers, they work great together. So now, last part of that, the green part, the most interesting part actually. So your application. And here we come finally to the benefits of Kubernetes, because from the previous parts, you might get an impression that, whoa, it's complicated, it's not worth it, maybe let's just not do it because there are no advantages. But that's not true. There are definitely advantages, and that's why people are so excited about Kubernetes. So what are the benefits from updates point of view? First of all, no matter how many applications you deploy, and no matter how many applications you have, you get the uniform management interface. So it's like easier to move people around teams because everyone is talking the same language. Everyone is managing the application using the same set of components. And that's like a great unification. Second thing that is important for updating your software is rollouts. So basically, rollouts are first-class citizens in Kubernetes. When you do a rollout, the rollout is fully controlled and automated by Kubernetes. So Kubernetes runs thing that is called health checks. So if you configure that, it will check every replica of your application, which is called pod in Kubernetes. It will check every of your pods if it is alive. When you do a rolling update, it will use a special policy that you configure for your deployment. And according to this policy, when you want to release a new version, it will start a set of new pods, then check if the health checks for those pods evaluate green. If they do, then a number of old pods will be terminated, and then a new group of new pods with new version will be again created, evaluated for health checks, and then again, a part of your old pods will be terminated. So your rollout is fully automated. It is covered in regard to rollback. So if your health check fail, then there will be no rollout. Kubernetes will stop and wait for your decision about what to do with that. And it will also keep a history, rollback history for you. So basically, rollbacks first-class citizens, and it really makes your life easier. Also, Kubernetes, when it comes to managing your software, makes some advanced concepts very easily accessible and really well defined for you to use. Like the previous use case that I described in more detail around rolling out a new Kubernetes version, this obviously needs a few elements. This needs like replication, so your application runs in multiple copies. This needs a replica-aware load balancer that knows which pods are available, which pods are healthy, which are not, so that your traffic is always directed to the current set of healthy pods. So during the update, part of your traffic will get to the old pool of pods, part of the traffic will get already to the new pool, and this will seemingly transition from old pool to new pool, and you don't have to do anything about it to make it happen. It just works that way in Kubernetes. Additionally, it provides some stuff like availability zone spreading, so you can make sure that your workloads are dispersed around a data center or different availability zones of data center or cloud provider. There are some advanced concepts like disruption budgets. So for example, you can say that your deployment, if it has like X replicas, at most 3 replicas can be unavailable at the same time. And this restriction will be enforced even on the cluster admin level. So for example, if your cluster admin wants to drain 4 nodes at the same time, and those nodes are necessary to fulfill your restriction of at most 3 pods being down at the same time, even the cluster admin will be denied of draining that many nodes, because this will violate your disruption budget. So you can define the disruption budget for your application for the number of pods that you run, and Kubernetes will handle that, will make sure that nothing, like no scheduled, no manual interference will cause this budget to be overrun. Next thing, also important during updates when you have to care about stuff like load separation, like configuring firewalls or limiting privileges. This can also all be done automatically without any need for reconfiguration from your side. So this is where really Kubernetes excels and makes your releasing your application way easier. You can even bring this to the next level by introducing service meshes, which can make some additional use cases also very easy. So when you have a service mesh, it's easy to do like a canary release where you only redirect like 1% or 3% of your traffic to the new version. Then you watch it for some time, and only if everything is good, then you gradually increase the number, the fraction of traffic up to 100% that goes to your new deployment. But this webinar is not really about service meshes. This is a separate component from the Kubernetes cluster as such. You just have to remember that as everything, there's no free lunch. And basically, although they introduce a lot of nice features, they also introduce a critical layer to your cluster. And if this layer ever fails, your whole workload, your whole traffic will be stopped, and your workload will fail as well. So that's something to keep in mind. So hints about updates and deploying your software. The important part of updates and updating your software is to be sure that when you update your software, you update your tools, or you update your cluster, your services won't be interrupted. And to do that, Kubernetes already provides a lot of native concepts and native components that will make this easy for you, and in most cases automated. So my hint here is check also some more advanced concepts of Kubernetes, like node or region anti-affinity, like network policies, which act as a firewall in Kubernetes, pod disruption budgets that I already mentioned, readiness checks that I also mentioned in the like rollout scenario when new pods started for a new version are first checked for readiness, for health checks, and only if they pass, they are included in the pool of pods that are connected to the load balancer. Read about quotas and resource limits to make your updates safer. So for example, if you run into a bug that leaks resources, you won't kill the node, you won't overload the node because you use resource limits and you use quotas for your deployments. And also read about privilege limitation, pod security policies, because this also shrinks the potential problem surface that can act when your deployment goes bad. Okay. So that's it about updates. We covered all the three layers. Let me now just have a quick look at monitoring. As you've already seen, there's a lot to watch. So Kubernetes is a beast. You have a lot of components, and you need to focus probably on few layers. And my suggestion is to keep an eye on at least those elements of the cluster. So not only your software, it is obviously very important, but you need to start way, way lower. My suggestion is to start with node level resources, because every node is part of it's obviously it's part of your cluster, but what I have in mind is that stability of node and then stability of sets of nodes is the stability of your cluster, and thus of your workloads that you run on the cluster. So make sure that you are aware in your monitoring tool of node level resources. And one important thing to keep in mind is that containers are not virtual machines. The separation between containers is way, way weaker than the separation between virtual machines. So obviously resources are shared between containers or can be shared, but you have to remember that resources are not CPU and memory now, but also the kernel, and everything that kernel keeps is a set of shared resources as well. So stuff like the number of files open, the number of parallel network connections, the number of sockets used, and so on and so on. I've seen some really strange behavior in Kubernetes clusters that was related to shared resources in the Kubernetes data structure, in the Linux kernel data structures, and not in Kubernetes as such. Next thing, pay attention to your network. So there's a lot of internode traffic in Kubernetes. There's Kubernetes as such is oriented towards the microservices architecture, which is all about passing requests from one place to another. If your network is slow, if you have congestions, if you have some misconfiguration, this can impact your whole cluster. So be sure that you have some visibility on the network level. Next level is the cluster level, where we get again to the node level, which might seem strange because I've talked about nodes already. But over here, I mean node as a Kubernetes concept. So in Kubernetes, node is, well, a cluster node, but it has a set of very strictly defined resources like memory, CPU, disk space, and so on, available for running your pods. So this is not about operating systems level, this is about Kubernetes level visibility. And this is basically what is used by Kubernetes scheduler to decide where it can run your workloads, on which nodes. So it is important to keep an eye over here, the monitoring eye, so you know how many resources do you have left. Like, for example, if you expect some, I don't know, flash sale to go with your software, and you want to scale your software up because you expect higher traffic, you need to know somehow if you have resources in your cluster to start like 20 new pods or 100 new pods for your application, right? Next level, pod resources. This is pretty obvious, probably. Pods are the building blocks of workloads in Kubernetes. You probably want to set limits for them. There are some exceptions, but in general, you want to set limits. But you also want to check how your application is doing in reality against those limits. So are you overestimating your usage, underestimating your usage? Will you run into problems? Is your pod maybe slowed down? I mean, are you running out of your CPU quota? Or maybe are your pods memory killed because your application is using more memory than you permitted, and so on. So very important cases are involved around pod resources monitoring. Finally, we're not at your software yet, but we're close. It's tools. So basically, all of the tools that I mentioned, like the monitoring tools, service exposition tools, all of them, they all compose now part of your cluster. You need to monitor them as well. and only then it comes to your software. So basically, until you have a full visibility of what is going on in your cluster, in your platform, just monitoring your software won't be enough, because you won't be able to really dig into real issues, real problems that can arise when you run your cluster. So a few hints. First of all, in Giant Swarm, we use the open source monitoring stack. There are many solutions for Kubernetes already available, but if you want a recommendation and start with something that is open source and trusted and battle tested, this is a short recommendation list from me. First of all, for monitoring and alerting, use Prometheus. Prometheus recently has become the de facto standard for monitoring anything in Kubernetes. Every service, basically every project that I mentioned during this webinar, exposes monitoring metrics using the so-called Prometheus format. And a hint for you for building your software: if you build from scratch, you are not migrating existing workloads to Kubernetes, but you build something from scratch, there's no reason to go against the current, right? If everything is using Prometheus for monitoring, use Prometheus for your application as well. Libraries to make this available, to make this easy to implement, are available for any major programming language, and that will make your monitoring setup simpler. So Prometheus for collecting all the monitoring metrics and for doing alerts, because Prometheus already includes a component called alert manager that does alerting on behalf of your metrics. For data visualization, Grafana, that's quite obvious choice. Everyone's using Grafana basically, especially together with Prometheus. For node level monitoring, what we already said, there's a nice project called Node Exporter that will export really a lot of stuff about your operating system level and network interfaces level metrics. And this is very useful for debugging and checking your cluster capacity. And for monitoring Kubernetes itself, it's kubestate metrics, the project, which exposes pod level monitoring for you for every pod that you run on the cluster. So if you don't have a fixed stack, I think you really can start with that and see how it works for you. Next process that I wanted to touch, but like a little bit shorter right now, is around cluster management. And what I mean by cluster management, I mean basically cluster lifecycle management. So basically, I've seen companies that think that like Kubernetes is great in regard to separation, clusters can be multi-tenant, so we can basically run everything on a single cluster. That's true, but that's unfortunately not a good idea. So the model that Kubernetes uses for multi-tenancy is sometimes called soft multi-tenancy, because yes, there are a lot of mechanisms that can be used for separating workloads in Kubernetes, but it's still the same kernel. Basically, it comes down to kernel that is shared across all the deployments, all the pods that are running on a single node. So the end point is that you can break Kubernetes. It's not maybe very easy to do that, but it's also not very hard. If you run a really badly configured workload, this can result in like very heavy node load that will then make kubelet, the agent that runs on all the nodes, will make the kubelet fail its health checks. So Kubernetes will consider your node as failed. So it will think that it needs to restart all the workloads that were running on this node. So it will start more workloads on the nodes that you already have. So maybe they get overloaded as well and they fail as well, and you trigger a cascading failure or something like that. I've seen use cases that went exactly that path. So yes, it is possible to break Kubernetes cluster. So you should think about hard multi-tenancy. And hard multi-tenancy for Kubernetes basically means that you run multiple clusters. That's it. So think about running at least a separate production cluster. This is a must-have, in my opinion. So production is, well, very stable, very restricted in access, and you don't run anything like testing, staging, or dev workloads there. Best solution probably run at least dev clusters separately, test clusters, for staging your application, staging your releases, and then production. And this can get even worse. I mean, what if your company is so big that basically you are not really, it's not really possible for you to run the same group of clusters for the whole company, and you need to like separate for different teams, different projects, different areas, whatever. So suddenly your problem becomes in managing the clusters, not managing the cluster, but managing how your clusters are created, deleted, updated, and so on at scale. So yes, don't run a single cluster. That's the point. But also think about how you can run multiple clusters, and probably that's something you should think about even before you get started, because soft multi-tenancy still will give you, well, the opportunity, the chance of running into some issues that are hard to debug but impact the whole cluster. So when you run multiple clusters with the hard multi-tenancy model, you're limiting blast radius of bad releases, bad changes, of even security issues. So it does also limit the attack surface of your applications, especially with stuff like untested releases, development work, and so on. Obviously, it increases your cost because you need to run multiple clusters. Each cluster needs to have its own control plane nodes, so master nodes, and it increases your management complexity. So you need to be prepared to run multiple clusters, but how many you should run really depends on your use case. You need to think about your granularity. So definitely separate production from staging and development clusters, but then it's up to your use case, basically up to you, and depends on your use case. Should you create per team clusters, or maybe even separate development clusters for each of the developer? Maybe only per project, or should you create them on demand? Think about this, because it's not only about keeping your single cluster up, it can quickly turn into how do you provide more clusters, how do you create new clusters, update existing ones, and destroy the ones that you don't really need anymore. So really pay attention to that, because it can be harder than it seems. And one last area, one last process actually that I want to touch in this webinar is around security. And this one I will keep really very short, because the problem is that everything's security. So we went through the layers here, right? Like your infrastructure layer, Kubernetes layer, tools layer, and your application layer. There's security involved everywhere. A few hints, and just a few, because really security can be a series of webinars and not just a part of a single one, but just a few hints that will already improve your security situation with a very low involvement on your side, and are not that obvious to do. First thing, don't run root user images. What does it mean? When you build Docker images, they are usually, in most cases, run by the root user. Although there is this soft multi-tenancy separation into namespaces in your kernel and so on, so basically your pods run separated, it's still not a good idea, because it's still the root user. So basically it is the same user, the same root user that you run in your operating system. So
Ja, die sind schon
keep
richtig
that,
cool eigentlich. So. Aber ja, der Nachteil ist halt keine Tasche. Ne?
Sorry. So keep that in mind, okay? Next thing, scan your images. So when you build, Franz, we have some.
I think I'm muted. Sorry.
No, you're not.
No, actually, okay. I muted another user. Yeah.
Okay. Sorry, where we were. Okay, here. So yes, don't run root level images if only you can, because if you have some misconfiguration, this misconfiguration can then be easily used, easily exploited in an image that runs on root user. Second, use pod security policies. This is again a more advanced concept, and not many projects probably use that. Pod security policies allow you to enforce some restrictions on how your workloads are run on your users. So as an example, to connect with the point above, you can define a pod security policy that forbids to run images that run on root, on a root user. So that basically means that your teams are forced to not run root level images. There are many, well, not that many, but there are other use cases. This is just an example of what pod security policies can do, but be sure to check them. Another point that can be important for you, depending on your CI/CD configuration and how you release stuff, is involve some image scanning. It's today, like when you build a software, we tend to use so many libraries, so many externals, external provided libraries, open source libraries, and so on. But it's basically impossible to manually keep track of updates, bugs, security issues, and so on that are present in those libraries. So we need automation for that. There are two projects that I recommend to check, Trivy and Claire. Trivy is recently getting a lot of popularity and a lot of traction, so it's probably a good idea to check Trivy first, but they can both be used to automatically scan your images for vulnerabilities. Also, be sure to trace expiry dates of your TLS certificates. When you set up your cluster infrastructure yourself, remember that all the intra-cluster communication between the nodes, between the Kubernetes services and everything is TLS secured. This means certificates. Those certificates can run out of date and then, well, nothing works anymore. Also remember about customer-facing certificates. The stuff that you place in Kubernetes, yeah, it's automatically managed, automatically everything, automatically updated, but it can't, like, until you use some additional service, it can't automatically extend the validity and change the validity of TLS certificates that you use to expose to your users. So one of the source of the problems that I've seen also is that, like, people get a lot of confidence in Kubernetes and they are pretty confident that everything runs smoothly. They can do updates without any downtime, updates of cluster without any downtime. And then suddenly one day everything fails, like in a year when everyone forgot already about the issue because, well, TLS certificate runs out of date. And one last point, watch Kubernetes releases and CVEs. I've touched that already when talking about updates, but you really should pay attention to Kubernetes release notes. Pay also attention to CVEs. And, well, obviously, because it's not Kubernetes and not your application anymore, not only, you also have to pay attention to your tools, especially tools that are customer facing. So like ingresses, like service meshes, the stuff that is responsible for routing your requests from customers to your services, because they probably have the biggest attack surface out of all the services that you run. And with that, let me finish. Just a short summary. The most important conclusion is probably to remember that Kubernetes is not a single well-defined product. There are many pieces involved, but also there's a lot of customization for you to do. You can choose your projects, you can choose your monitoring stuff, you can choose your traffic related projects, a lot of things to choose, update, monitor, and take care for. Next important thing is that developing for Kubernetes and showing your platform, showing your application, exposing your application, running it for external customers needs, in my opinion, really quite good knowledge of Kubernetes and needs a healthy and stable cluster. So think about that, plan your important processes, especially updates, monitoring, cluster management, and make sure that you have resources to do that. because this is a process. This is something that will last for as long as you run Kubernetes. And you need to have people for that. You need to have a team or teams that will specialize in that and that will keep your Kubernetes healthy and up. And remember that basically Kubernetes really encourages the DevOps culture approach. So it's not just your applications code anymore. It's also how you release your stuff. It's about the code that describes how your application is built on top of Kubernetes. It's about the code that releases your tools, that updates them, that manages your clusters, and so on and so forth. So infrastructure is not magic. The way the infrastructure runs is definitely directly connected to how your application run, how satisfied your customers are. And just to end with what I started, it's basically all about automation. So thank you very much. I will now pass the microphone back to Franz.
Yeah, thank you very much, Lukasz. That was really insightful and lots of information there. I'll actually just collecting some questions. We already have some coming in. In the meantime, I'll just show you what we actually have done to speed up cloud native journey. We actually tried out different approaches, as you can quickly see through our history together with our customers. What we then did is that we basically came up with a model where we actually help and take over the management of Kubernetes for customers, so they actually don't have to worry about anything that Lukasz took us through. But naturally, teams will always grow. So we actually share our knowledge, just like we shared in this webinar. We share it together with our customers through the installation phase of Kubernetes, but also ads that will kind of evolve along your cloud native stack. Make it secure, manage it, monitor it 24/7, fix it if we actually identify anything, make sure that no customer runs into the same problem we identified with another customer. That's where we do 500 to 600 postmortems every year, where we basically deploy these patches to the Kubernetes platforms instantly, and then naturally do the upgrade with them very frequently. So it actually gets a habit, and it actually is less painful. And the goal is actually that instead of doing everything yourself, you actually can, naturally use public cloud provider offerings or third-party platform providers, or you can use Giant Swarm, where we, manage everything for you. But then naturally, there are tons of things to do around Kubernetes, and we actually can help you accelerate that journey. That's what we actually do as a business. Now, coming up to the questions and answers, we actually have two, hopefully, that you can answer.